Hey guys, Mr. Backerberg here. In this video, we're going to take a look at substitution in indefinite integrals. So when we're integrating, sometimes a change in the variables can turn an unfamiliar integral into something that we can more easily evaluate. Now, an important point to remember is that it's not sufficient to change an integral of the form integral of f of x dx into the integral of the form the integral of g of u dx. That differential on the end matters. Changing this from f of x to g of u, we also have to change that differential on the end. We can't leave it as a dx. So to do a complete substitution, we have to change that integral of f of x dx into the integral of g of u du. So not only making an adjustment to the function that we're integrating, but also changing that differential on the back end. So as we're looking at this example, we're going to use some substitution to help us evaluate the integral of the sine of x times e to the cosine of x dx. And when we're doing substitution, we want to be very careful about what we do the substitution with. Now, as I'm taking a look at this problem, I see this e in here. And we should remember that e to the x is easy for us to integrate, because if we do the integral of e to the x, it just stays as e to the x. So if we could somehow get this to say e to just a variable power, that should be easier for us to do the integration with. So what we're going to do is take that power on our e, that cosine of x, and we're going to let u equal the cosine of x. Now, when we figure out what we're going to let u equal, we're also going to do the derivative of this equation right here. So then, this is going to say du equals negative sine of x dx. And that's going to come into play a little bit later on when we look at adjusting this differential on the end so that we can get du involved there. So the first thing I'm thinking about is that we've got that u equaling the cosine of x. So right here we've got e to the u power. We've still got that sine of x in the front, and we've still got that dx on the end. Now, we said that we also needed to change the differential. So, using this derivative of our u equation that we just got earlier, we're going to solve this to get dx alone. So, to take this negative sine of x over to the other side, I'm going to treat it like dividing. So then this will say that dx is equal to du divided by negative sine of x. And then what I can do is take this and substitute it in for the dx in our integral. So then this will say the integral of the sine of x times e to the u. And now we're getting rid of the dx and we're replacing it with the du over the negative sine of x. And now what's going to happen in here is we can actually do a little bit of rearranging. Instead of dividing the du by that negative sine of x, I'm actually going to bump that to the front where this other sine of x is. So this will be the integral of the sine of x over negative sine of x. And then we've got our e to the u power and our du. And then if we do this division in here, sine of x divided by negative sine of x, that turns into a negative 1. So we've really got negative e to the u du. Now this is almost ready to do the integration on. We've technically got a constant multiplier in front with that negative 1. So properties of integrals, we're allowed to pull that negative 1 out to the front. So then this will say the negative integral of e to the u du. Now we're going to do the actual integration. And when we integrate e to the u power, that's just going to stay as e to the u. We've got that negative out in front, so we need to keep the negative on there. And when we do an indefinite integral, we need to remember to put our plus c on the back end. Now we're not done here because u wasn't the variable in our initial problem. X was the variable. So what we need to do is remember the substitution that we did earlier on. We said that u was equal to the cosine of x. So once we do the integration, we need to fill that cosine of x back in for the u in here. So then this will be negative e to the cosine of x plus c. This is going to be our indefinite integral answer. Now we could check our answer by doing the derivative of this thing that we just ended up with, and we would see that that factor of sine comes into play from when we have to do the chain rule with that functional power of our e. So when we're doing integration by substitution, that kind of reverses the effects that the chain rule has on a problem. Now taking a look at this example, we've got the integral of x squared times the square root of 5 plus 2x cubed dx. Now the tricky part on this one is that square root. So what we're going to do is let u equal the stuff underneath the square root, so the 5 plus 2x cubed. But then, just like we did on the previous one, we also have to do the derivative of this equation. So that's going to say du is equal to, now when we differentiate the 5, that just turns into a 0, so we don't need to keep that on there. Doing the power rule with the 2x cubed, drop the 3 down and multiply, so we get 6x, and then we have to subtract 1 from the power, so that becomes a squared power, and then we get our dx. Now I'm going to solve this to get dx alone right away, so I'm going to divide that 6x squared over to the other side. So then this will say dx is equal to du over 6x squared. And now I'm going to do my substitution. So we've got the integral of, we're going to leave the x squared for now, but then we've got this square root. We're getting rid of the stuff underneath the square root because that's what we let u equal. And then we're going to get rid of that dx and replace it with the du over 6x squared. So du over 6x squared. But then we're going to rearrange this to hopefully get some things to cancel out like we saw in the previous problem. So I'm going to take this division with the 6x squared that's happening, and I'm going to bump this up to the x squared over here. So this will say the integral of x squared over 6x squared times that square root of u, and now this is just a plain du on the end. Now doing the dividing in here, these x squareds are going to cancel each other out, so then this will really be the integral of 1/6 times the square root of u du. With that constant multiplier of the 1/6, we can bump that out to the front. So 1/6 integral of. Now square roots might be kind of tough to do the integral of, so I'm actually going to write it as a 1/2 power. So u to the 1/2 power du. And then we can use our anti-power rule to help us do the integral here. So this will be 1/6 times, we're going to take that u, but we're going to add 1 to the power. Well, if we add 1 to a half, then that becomes 3/2, but then we want to divide by that 3/2, and then we throw our plus c on the back end. Now this is going to take a little bit of cleanup work. We don't typically like to divide by a fraction, so instead of dividing by this 3/2, we're going to multiply by the reciprocal. So we're going to multiply by 2/3. Now we're going to be able to do a little reducing with that 2/3 and that 1/6. So this 2 will turn into a 1, this 6 will turn into a 3. So we're really going to end up getting 1/9 times our u to the 3/2 power plus that c on the back end, but then we're not done. U wasn't the variable in our problem, so we need to get rid of that u and replace it with what u was equal to. So we're going to have 1/9 times, u actually represented 5 plus 2x cubed, but then we've got the 3/2 power on that, and we've got our plus c on the back end. So this will be our indefinite integral answer. And again, we could do the derivative of that to check our answer, and it would give us back that original problem that we started with because of the chain rule. In this example, we're going to look at evaluating the integral of the cotangent of 7x dx. Now, we can't actually do any substitution right away. We're actually going to have to use a trig identity first and then do some substitution with it after. So, looking at that cotangent, if we use a trig identity, one of our quotient identities, cotangent is cosine over sine. So when we have the cotangent of 7x, we can turn that into the cosine of 7x over the sine of 7x, and then we've got our dx on the end. Now what we're going to do with this is we're actually going to let u equal the sine of 7x, and then we're going to have to do the derivative of this. So that's going to say du is equal to, now when we do the derivative of sine, that turns into the cosine. We're going to leave the 7x, but then this is actually a chain rule problem. We have to do the derivative of the stuff on the inside of the parentheses. And the derivative of the 7x is just 7. So I'm going to put a 7 in front of this, and then we've got our dx on the back end. And similar to what we've been doing before, I'm going to solve this to get dx all by itself. So this will say dx equals, I'll have to divide this stuff over to the other side. So this will be du over 7 cosine of 7x. And then I'm going to do my substitution. So this will be the integral of the cosine of 7x over our u value. And then on the back end where we've got the dx, we're going to replace that with du over 7 cosine of 7x. Now what I notice in here is that this cosine of 7x on the top left is going to cancel out with this cosine of 7x on the bottom right. Now when I write out my integral, I'm going to rearrange it just a little bit. So this will say the integral of 1 over 7u du. Now having this 7 on the bottom of the fraction, there is actually a constant multiplier that we can pull out front, and it's going to be 1/7. So then this will say 1 over u du. Now this 1 over u, when we have 1 over u, that's going to integrate into the natural log of the absolute value of u. We've still got that 1/7 on the front, and then we have to put our plus c on the back end. And now we're almost done. We just have to re-substitute what we know about u. So we knew that u was equal to the sine of 7x. So this will be 1/7 times the natural log of the absolute value of the sine of 7x plus our c value. So here's our indefinite integral answer this time. Now, just like we saw in the previous example, there are going to be times where using a trig identity is going to be helpful before we do our substitution. So in this example here, we've got the integral of dx over cosine squared of 2x. Now, I'm actually going to write this as the integral of 1 over cosine squared of 2x dx. I think that helps us see a little bit better what's happening in here. Now we're going to use a reciprocal identity. 1 over the cosine is the same as the secant. So we can turn this into the secant squared of 2x dx. And then what we're going to do in here is let u equal 2x. And then if we do that derivative, then du is going to equal 2 dx. I'm going to solve that to get dx all by itself. So dx is equal to du over 2 by dividing that 2 over to the other side. And now we're ready to do our substitution. So we've got the integral of the secant squared of u, and then we'll have du over 2. Now having this du over 2, the constant multiplier in there that we can pull out in front is really 1/2. So then this will be the integral of the secant squared of u du. And then if we look at doing the actual integration, secant squared integrates into the tangent. So we're going to have 1/2 times the tangent of u plus our c value on the back end. That's our integral, but now we need to get rid of the u that's in there and replace it with what we know about u. So we knew that u was equal to 2x. So this will be 1/2 times the tangent of 2x plus our c value on the back end. So this will be our indefinite integral answer this time. As we look at this example, we've got the integral of the cotangent squared of 3x dx. We're going to use a Pythagorean identity right away here. Cotangent squared can be turned into cosecant squared minus 1. So this will say the integral of the cosecant squared of 3x minus 1 dx. Now when we do our substitution, we're going to let u equal 3x. So then du is equal to 3 dx. Solving to get dx all by itself, this will say dx equals du over 3. And now I'm going to do my substitution. So this will be the integral of the cosecant squared of u minus 1. And then we'll have du over 3. Now having this du over 3, I'm going to pull 1/3 out of here. So then this will be the integral of cosecant squared of u minus 1 du. Now we're going to do the actual integration. So we'll have 1/3. Now cosecant squared is going to integrate into negative cotangent of u. And then this 1, we'll have to put a variable on that. So that's going to turn into a minus u. And then we'll have to put our plus c on the back end. Now remember, u wasn't our variable, x was, so we're going to get rid of the u in here and replace it with the 3x that we knew that u was equal to. So this will say 1/3 times negative cotangent of 3x minus 3x plus c. And then if we want to, we can take that 1/3 that's out in front and distribute that through. So this will say negative 1/3 cotangent of 3x minus, now when I take the 1/3 times the 3x, those 3's are going to cancel each other out, so we'll get just a regular x, and then plus c. So this is our indefinite integral answer this time. One more example that we're going to take a look at here. So we've got the integral of the cosine cubed of x dx. Now we don't have any trig identities for cosine cubed, but we do have a trig identity for cosine squared. So what I'm actually going to do is rewrite this as the integral of the cosine squared of x times another cosine of x dx. And then I can use a Pythagorean identity to get rid of that cosine squared and turn it into 1 minus sine squared of x. But then we still have this extra cosine of x on the back end and our dx. Now this time we're going to let u equal the sine of x. So then du is going to equal the cosine of x dx. Solving this to get dx alone, we'll get dx is equal to du over the cosine of x. And now we're ready to do our substitution. So we're going to have the integral of 1 minus, now we're letting u equal the sine of x, so this is sine squared, so this will be u squared times our cosine of x. And then for dx, we're going to get rid of that and replace that with du over the cosine of x. Now notice this times cosine and this divided by cosine in here, those are going to cancel each other out. So now we've got the integral of 1 minus u squared du. Now if we do the actual integration, when we integrate the 1, that just turns into a regular u, minus, when we integrate that u squared, we're going to have to use our anti-power rule. So take the u, add 1 to the power, but then divide by that number, and then we throw our plus c on the back end. Now we're not quite done because we had to remember that u was equal to the sine of x. So this is going to say the sine of x minus the sine cubed of x over 3 plus c. And that's going to be our indefinite integral answer this time. That's going to be it for this video. Thanks for watching.